Okay, so what you guys know about trig so far is that we use it when we have right triangles and we're asked to find missing sides or angles. Okay? But what if we're not given a right triangle? What if we're given, well, we call it a non-right triangle, or the other name that we give it is an oblique triangle. Okay? Oblique. So here's an example. You're given two angles in a non-right triangle, one of the sides, and you're asked to find one of the other sides. So how can we do this? Well, I mean, it is possible to use right triangle trig if we took this non-right triangle, drew an altitude or a height, and created two right triangles. So what we could do, and we did this last year, because we did trig with two right triangles. We could focus on this blue one here, and we could find the missing height using right triangle trig. So what would the trig equation look like? Focusing on the blue right triangle. How would we set it up? What trig ratio are we going to use? Sine. So the sine of the angle, 65 degrees, is equal to the opposite side, which we're trying to find, h, over the hypotenuse 10. And we should be pretty comfortable with this right now. To find h, well, times both sides by 10. And that will get h by itself. And 10 times the sine of 65 will give you about 9.1. So now we know that this is 9.1. Well, this height that we drew not only was part of this right triangle we created, it's also part of this right triangle that we created. And since we now know that this is 9.1 and we've got an acute angle, we can find the missing side B. And we would use sine again, because we've got 30 degrees, we've got the opposite, we're trying to find the hypotenuse. So the sine of 30 degrees will equal 9.1 divided by the side we're ultimately trying to find. Got to get b by itself. Well, here I got to do a couple of steps. I have to multiply both sides by b. So I get b sine 30 degrees is equal to 9.1. Still don't have b by itself. So divide both sides by sine 30 to figure out what b is. And when we do that, we're going to get exactly 18.2. So that's how we figure it out. Well, that's a fair amount of work. Okay? Mathematicians are lazy. We like to look for shortcuts. There is a formula that we can use that blends these two together into one calculation. And it's called the sine law. Okay? And I've, at the end of this lesson in your notes, I've given a proof of the sine law, like where the formula comes from. You don't need to worry about it, but I always like to sort of add where it comes from. But essentially, this is what the sine law looks like. So here we have this non-right triangle oblique triangle again. And I've labeled the vertices or the angles ABC, capitals, and the sides little a, little b, little c. Well, the ratio of little side A over the sine of capital A, the angle, will equal the same value as the ratio of little side B over the sine of its angle opposite, which is capital B. And that will equal the third side, C, little c, over the sine of its angle opposite, capital C. This is a formula you will always get. Okay, so you don't have to worry about memorizing it. I'm more concerned with, can you use it? Where do we use sine law? Because sometimes sine law isn't going to work. I need to change this. I just want you to take this out. Because really, I can sum it up to this. When we know a side and its opposite angle. That's really when we use sine law. Acting up once again this morning. Right? Let's get rid of this thing. Come on, go away. Go away. Wow, okay. Forget about that. So if I went back and did that same question using sine law, I'm going to get the same answer. So if I went back here to this one, and I'm going to use sine law, so I'm going to use it here. Well, first of all, I'm going to erase all this so we can just see the original non-right triangle. You'll notice that in this one, I'm given a side and its angle opposite. Okay. Therefore, I can use the sine law formula. So here's how I would set it up. I would say, okay, I'm given this side. I know its angle opposite. So that ratio, written in fraction form, is going to be 10 over sine 30. The other ratio in my question, here written in fraction form, is going to be the side I'm trying to find over the sine of its angle opposite. E over sine 65 degrees. And according to sine law, those are equal to each other. Okay? So we've got a fraction equation with a single fraction on either side. There is a way to clear the fractions. Like if you think about this, if I had to clear the fractions, I'd have to multiply both sides by sine 30 to get rid of this. Then I would have to turn around and multiply both sides by sine 65 to get rid of the second fraction. There is a quicker way where we use cross multiplication. When we have a single fraction on each side in an equation, the product of the diagonals will equal each other. So b times sine 30 will equal 10 times sine 65. And the fractions are clear. How do I get b by itself?
Divide by sine 30.
Divide by sine 30. Divide by sine 30. So how am I going to find b? I'm going to do this big calculation on my calculator. So when you do the 10 times sine of 65, get that answer and divide it by sine 30, you should get 18.2. Which is obviously the same answer we got when we used right triangle trig twice. But this is much quicker, because we don't have to do two different calculations. We can do it all in one. Okay. Well, let's practice with another one. This one down here. Yeah.
I got 18.41 instead, but it's essentially the same.
Yes, it is. Yeah. Okay. Well, in this one, we know a sine and its opposite angle, so we can use sine law. So what I would do is say, okay, I'm going to take the sine I'm given and its opposite angle, and that's going to be my first fraction, 7.2 over sine 63 degrees. That is going to equal the unknown side I'm trying to find over the sine of its angle opposite, 71 degrees. So C over sine 71. And you've got your equation. Cross multiply to clear out the fractions. And you should be left with C times the sine of 63 degrees equals 7.2 times the sine of 71 degrees. After the cross multiplication. And then to find C, I need to divide both sides by sine 63 degrees, divide by sine 63 degrees, and then do those calculations on the calculator. And I end up with an approximate answer, if I go to one decimal place, of 7.6. Okay. Okay, let's look at two more. So here we have another non-right triangle. We're asked to find the missing side labeled D, and you can see the other information that we're given. Okay. Well, if you look at this initially, you would say, well, I'm not given a side and its angle opposite, because I have B, I have its angle opposite. This side has nothing to do with the question. And I have 5, but I need to know this to use sine law. Can I find it? Yes. Because I know the two other angles, to find it, all I do is just 180 and subtract away those two other angles. And you get 45 degrees. Now you've got a side and its angle opposite. So see if you can set up the equation. See if you can set up the sine law equation. And then once you have that set up, follow it through. So your initial equation should look like that. Cross multiply and fill the fractions. So your equation now looks like this. Divide both sides by sine 45 to get b by itself. Now you're ready to use your calculator. And get an approximate answer to the nearest whole number of 7. Good. Okay. So that's how we find missing sides using sine law. Okay. Sometimes the information is all given that you need. Sometimes you have to figure out the third angle before you set up the equation. What about finding the missing angle? Okay. So here we have an example. We see that we're given a side and its angle opposite, which means we can use sine law. So I'm going to set it up 14 over sine 39. But the other fraction on the other side of the equal sign will be 21 over sine x. So this time the unknown is the angle, not the side. And whenever you're finding an angle using trig, you should be thinking to yourself, at the end, I have to use sine inverse. So once again, cross multiply to clear the fractions. So I'm going to get 14 times the sine of x. Notice I put the unknown on the left side. 21 times the sine of 39 degrees. If you had 21 sine 39 here and 14 sine x here, that's still right. That's still fine. I got to do two things to get x by itself. First of all, I have to get rid of the times 14 by dividing 14. Now I've got it down to just sine x. What do I do to find just x? No, not divide by sine. To get rid of sine only, we always use sine inverse. Which means I got to take the sine inverse of this whole side. And a way you can do that on your calculator is just go sine inverse, open a set of parentheses, and then you should be able to do 21 times sine 39 divide 14, and then close that set of parentheses. And that should give you the angle. With most calculators, you might have to put an extra set of parentheses with some. But you should have got 71 degrees. Okay, sometimes like you just go sine inverse. So second or shift, whatever you have there, and then open up a set of parentheses and then type this in. Sometimes when you press sine on some calculators, it automatically opens up a set for the angle. So you may have to close parentheses twice, possibly. Okay. But if you do it correctly, you should get 71 degrees, because we're asked to round to the nearest degree. So that's sine law. And that helps us find missing sides and angles in several non-right or oblique triangles, but not every one. We'll come across ones where we can't use sine law. So we need a different formula that we'll talk about later. And that's it.